The names of compounds in a homologous series are based on the names of the basic carbon chain modified by a prefix phrase before or suffix phrase after. Identifying the number of carbon atoms in the compound, a compound having 3 carbon atoms would have the same propane. Same name, propane, okay. In case of a functional group is present, it is indicated in the name of the compound with either prefix or suffix. If the name of the functional group is to be given as a suffix and the suffix of the functional group begins with a vowel A, E, I, O, U, then the name of the carbon chain is modified by deleting the final E and adding the appropriate suffix. Propane. Propane plus ONE gives propanol. Okay. If the carbon chain is unsaturated, then the final name A and E in the name of the carbon chain is substituted by ENE or YNE. Let us see the examples which are given in the table 4.4. Haloalkane, prefix chloro-bromo, and see the structure chloropropane. Then bromopropane, alcohol, suffix OL, propanol, aldehyde, ketone, carboxylic acid, alkynes, ENE, alkynes, alkenes, ENE, alkynes, YNE. So we get propane, propanoic acid accordingly. Okay. Now we come to the chemical properties of carbon compounds. Combustion. Carbon in all its allotropic forms burns in oxygen to give carbon dioxide along with the release of heat and light. Most carbon compounds also release a large number of heat and light on burning. These are the oxidation reactions that you have learned in the first chapter. C plus O2 gives CO2 plus heat and light. Methane plus O2 gives CO2 plus H2O plus heat plus light. So you can see the reactions. Saturated hydrocarbons will generally give a clean flame, while unsaturated carbon compounds will give a yellow flame with lots of black smoke. Just read, why do substances burn with or without a flame? Formation of coal and petroleum. The next is oxidation reaction. So you can see the reaction which is given here. Alkaline potassium permanganate or acidified potassium dichromate are oxidizing agent. Alcohols to acids, that is adding oxygen to the starting material, hence they are known as oxidizing agents. Next we have addition reaction. So you can see the example. Unsaturated hydrocarbons and add hydrogen in the presence of catalyst such as palladium or nickel to give saturated hydrocarbons. Catalysts are substances that cause a reaction to occur or proceed at a different rate without the reaction itself being affected. Next is substitution reaction. Saturated hydrocarbons are fairly unreactive and are inert in the presence of most reagents. However, in the presence of sunlight, chlorine is added to hydrocarbons in a very fast reaction. Chlorine can replace the hydrogen atoms one by one. It is called a substitution reaction because one type of atom or group of atoms take the place of another. A number of products are usually formed with the higher homologous of alkanes. CH4 plus Cl2 gives CH3Cl plus HCl in presence of sunlight. Some important carbon compounds and ethanoic acid. Properties of ethanol. Ethanol is a liquid at room temperature. For melting and boiling points of ethanol, ethanol is commonly called alcohol and is active ingredient of all alcoholic drinks. Reactions of alcohol. Ethanol reaction with sodium. Alcohol reacts with sodium leading to the evolution of H2 with ethanol. The other product is sodium ethoxide. You can see the second reaction. How do alcohols affect living beings? Then alcohol as a fuel. Properties of ethanoic acid. Ethanoic acid is commonly called acetic acid, CH3COH, and belongs to a group of acids called carboxylic acid. 5 to 8% solution of acetic acid in water is called vinegar and is used widely as a preservative in pickles. The melting point of pure ethanoic acid is 290 K and hence it often freezes during winter in cold climates. This gives rise to its name glacial acetic acid. Now we go to the reaction of ethanoic acid. Esterification. Esters are most commonly formed by reaction of an acid and alcohol. Ethanoic acid reacts with absolute ethanol in presence of an acid catalyst to give an ester. Esters are sweet smelling substances. These are used for making perfumes and as flavoring agents. On treating with sodium hydroxide, which is called an alkali, the ester is converted back to alcohol and sodium salt of carboxylic acid. This reaction is known as saponification because it is used in the preparation of soap. Soaps are sodium or potassium salts of long chain carboxylic acid. Formation of ester, see the figure 4.11. Now you can see the various reactions. Now we come to soaps and detergents. Formation of micelles. The action of soaps and detergents are based on the presence of both hydrophobic and hydrophilic groups in the molecule, which helps in emulsifying the oily dirt. So you can see the activity and figure 4.13, effect of soap in cleaning. This problem is overcome by using another class of compounds called detergents as cleansing agent. Detergents are generally sodium salts of sulfonic acids or ammonium salts with chlorides or bromides ion. Both have long hydrocarbon chain. Detergents are usually used to make shampoos and products for cleaning clothes. Now let us see what you have learned. Carbon is a versatile element that forms basis for all living organisms and many of the things we use. This large variety of compound is formed by carbon because of its tetravalency and the property of catenation that it exhibits. Covalent bonds are formed by sharing of electrons between two atoms so that both can achieve a completely filled outermost cell. Carbon forms covalent bonds with itself and other elements such as hydrogen, oxygen, sulfur, nitrogen, and chlorine. Carbon also forms compounds containing double and triple bonds between carbon atoms. These carbon chains may be in the form of straight chains, branch chain, or rings. The ability of carbon to form chains give rise to homologous series of compounds in which the same functional group is attached to carbon chains of different lengths. The functional groups such as alcohols, aldehydes, ketones, and carboxylic acid bestow characteristic properties to the carbon compounds that contain them. Carbon and its compounds are some of our major sources of fuels. Ethanol and ethanoic acid are carbon compounds importance in our daily lives. The action of soap and detergent is based on the presence of both hydrophilic and hydrophobic groups in the molecule, and this helps to emulsify the oily dirt and hence its removal. So now read the lesson again and write down the answer of the exercises. Thank you.